Good morning students, I am Vetti Chelvi from Vetti and Vetti Neat Chemistry. Today I am going to give one video related to the organic chemistry. This is the question I am selecting from the NTA ABHYAS-2. Okay. Now let us see the first question. Choose the correct statement about the major product formed in the U2 reaction of this reactant. Okay, now the options are here. Major product is optically active and this one is given trans, cis and another one. Okay, now here let us how to do it. First to work is we have to convert this one as a Fisher projection format. Since these things are given in the same direction towards the up, we are going to draw the eclipsed form. So to draw the eclipsed form, first I am labeling this carbon as a 1 and this carbon as a 2. Okay, based on that, let me give them diagram. First one, circle. Here this is one carbon. Okay, another one, this is. Okay, now let us write the carbon. This is the first one, the inner one. This is the carbon number 1 and this is carbon number 2. In the carbon number 1, hydrogen is the upward position and this ethyl group is this one towards the observer. You are writing on my right hand side, that is ethyl group, you can write as a ET, and this is away from the observer, the methyl group I am writing here. This is in the carbon number 1. Carbon number 2, already I told this is on same direction, so I am going to give the eclipsed form. So eclipsed form means now here for this I am giving the second carbon. On the second carbon next to this I am putting diagram line. After this I am putting line. So these are the 3 bonds belonging to carbon number 2. Now let us on the carbon number 2, Br is on the upward direction, write Br, and this hydrogen, this is towards the observer. So I am putting on my right hand side. Methyl group away from the observer, I am putting on my left hand side. So this is carbon number 1 and carbon number 2 and eclipsed form is given. So now what is happening in the E2 reaction? It has to tilt in the 180 degree. So during the 180 degree, what is happening is carbon number 2 don't changes, only carbon number 1 is going to change. Now let me give the diagram of it, the newly formed one. This is carbon number 2. This is carbon number 1. Already I told in the carbon number 1 only we are going to rotate. So now what is the line is given in the carbon number 1 and rotate is 180 means this totally upside down. So these two become going that direction. So upward bond angle for carbon 1 is bond is I am giving like this. Okay, what happening? The hydrogen is coming down. This is. The ethyl is going here. So this is ET. The methyl is coming here. This is on the carbon number 1. On the carbon number 2, there is no change at all. So this is standing there, no change. So there itself we are putting here and here. Same atoms are the Br and here it is hydrogen and here the black one. Yes, this is methyl. So this is after what is called rotation. What we are getting is the staggered form. So from the staggered form, what is you have to do with the what is given as the sodium methoxide, that is called dehydrohalogenation minus HBr. This is the nature of the reagent. So what is happening here is dehydrohalogenation. Hydrogen is coming with the what is called as a H plus ion. So this bond is shifting inside. Okay, the Br is coming along with the bond. So this is happening minus HBr. Now what is forming is in between the carbon number 1 and 2, the double bond. This bond is coming and form a double bond. Now I am giving the new bond. This is now the product I am giving. This is your product. You put this carbon. The pink color carbon 1 is written here. Then the next one is carbon 2. Okay, in the carbon this is here Br is there and here. So the Br is from the carbon number 2. So remove it. So on the carbon number 2, these 2 blacks I have to put it. 2 blacks. This hydrogen you put here. The methyl group you are putting here. So this is the bond. 2 bonds are there. This is on the carbon number 2. on the carbon number 1. So this is the pink color. So what is you are removing? H is removing. So what else you are having is on the carbon number 1, you are having hydrogen removed, methyl and ethyl. Methyl you bring it on this side, that is on right hand side. The ethyl you bring it on this side. This is your ethyl group, Et. So now name the product now. Here let us go into the numbering of this is ethyl group. So numbering I am doing. This is carbon number 1, this is 2, this is 3, and here ethyl group mean it is CH to CH. I will give us a 4 and 5. So total carbon 5. Here the methyl groups both are in the opposite direction. So this is labeled as trans. First you put the trans. Then what you are going to put it, the methyl group is on which carbon number? This is on the 3. So trans 3-methyl. 3-methyl. And then what is it? 5 carbon is there. So it is the pentene. Double bond is after carbon number 2. So 3-methyl penta-2-ene. This is your name of the product. Now go and see it. Trans. First let us go and see. Here it is given as the trans. Here it is major product will be optically active. It is given. It is not correct. Why it is not correct is because the product is with the double bond where the asymmetric carbon atom is not with the sp3. So it is not optically active. Next one is trans we are getting. So now compare my naming. Trans 3-methyl 2-pentene. Trans 3-methyl penta-2-ene. Penta-2-ene both are same. So this is the correct answer. I am taking. This is the my answer is B. Okay, the C is given. So B is answer. So this is not correct. And the next one is also not correct. Okay, with that here what is the important tricky point is this what form is, it is the eclipsed form. You are putting as the staggered form. During the staggered form the carbon atom one only, on that one only the bond rotation takes with the 180. That is called 180 degree it is rotated. So the position is getting changed. After that you remove the dehydrohalogenation and you are getting the product and name it. The question is very simple. The knowledge is here only. Okay, we are going to the next question is the simple IUPAC name. Okay, here two functional groups are there. Here one functional group is here it is should be this is your hydrogen. Okay children. Okay. So now this is your aldehyde group. This is your keto group. Order of priority is for the aldehyde group. Numbering start. Here 1, 2, 3, and this is 4 and this is here what is a 4. 1, 2. Okay children, in this compound we are having two functional group. One is aldehyde group, another is keto group. So among the aldehyde ketone, the priority should be given for aldehyde. So starting from here 1, 2, 3, 4, 5, 6. So totally you are having 6 carbon atom. Let us go and see anything is 6 means that we will select. It is hex, you can take it. Of course, this one you can take it as a hex. So all are hex, we cannot eliminate anything. Let us see here. So next point is, what is the next point is, your on the carbon atom 3 is the keto group. Now I am writing the name of the compound here is a keto and this is the methyl group. Among these two, who is coming alphabet first means keto is coming first. So let me write now, the coming first is the keto group, 3 keto. And then what is it is the 2-methyl. So 3 keto, 2-methyl. Overall carbon atom is 6. Among them you are having the, after 4 you are having the double bond. So 3 keto, 2-methyl, 6 carbon is there. Okay, so 2-methyl, hex, 4-ene and Al. This is the name of it. Let us go and verify. 3 keto, you are having two things are there. 2-methyl, till that both are the correct. Next one is here 4-ene. So now this is 4. So this should be the, my option is your A. So now here the only the difference is 4-ene. What is the difference here is the 5-ene. What is the meaning of it? After carbon 4 only you are having double bond. So your option number A is correct. Again here point is 2 functional group, aldehyde should be given priority. So you are selecting and going. Beyond that, the question is very simple. Now we are moving to the next question. Here it is cyclohexene on ozonolysis followed by the reaction with the zinc dust and it gives the compound E. The compound E and further rearrangement with the aqueous potassium hydroxide compound F is given. This is the based on ozonolysis and then intramolecular aldol condensation. Now let us write cyclohexene on ozonolysis. First let us give them formula for cyclohexene. This is your cyclohexene. This is your cyclohexene. Followed by ozonolysis is O3. The second one is in presence of zinc dust. Okay, what we should put it here? Break it and put the CHO. So now I am putting here. This is CHO and then here carbon. This is carbon 1 and this is 6. So this is 1 is over 2, 3, 4, 5, 6. So like that you have to do it in the faster manner. And here it is 1, carbon number is 6. So this is you are getting as a product of ozonolysis. Next thing is what is given is you here water gives E and common for the treatment with the aqueous potassium hydroxide. What is the knowledge is aqueous potassium hydroxide? The knowledge is intramolecular aldol condensation. So this is intramolecular aldol condensation because it is aqueous base. Now what is happening is this one is going to attack on this carbon. Okay, now let me write here this one carbon with the double bond is become O minus and this is H and write this is a number of carbon atom is very important one to follow it. Okay, now here it is 2, 3, 4 and this one, this carbon is going to attack. Here one correction I am doing children. Of course, this 5 is going not here, this is coming from here because this is the alpha hydrogen atom. Okay, now here carbon number 1 and it is 2, 3, 4. I want a 5 should be attached with the here. So that is the numbering is very important and the carbon number 6 is coming out as a aldehyde. So now this is the important point. So one carbon chain is carbon is reduced. Now what is remaining is next what it is going to attack formation of this is aldol product. Next what is going on? This is on heating beta elimination of water minus water it is beta elimination. Now here functional group this is aldehyde, this is beta and in between alpha beta the product should be the alpha beta product. So to write the alpha beta product in between this you have to remove the hydrogen. OH is removed and the hydrogen here you are having one hydrogen it is coming up the bond is shifting. Now let me write the product carbon number 1 and 5 double bond is formed. Now let us draw the one pentagonal structure. Okay, I am giving this is carbon 1, 2, 3, 4, 5 numbering is important. 1 and 5 put the double bond. On the 5th carbon atom you put the your aldehyde group. So this is the product. Now verify with the product hexagonally alpha and beta. This is easy for follow up. Alpha and beta unsaturated. So this is your option. Here in between not, so it is not a correct answer. So these are the not correct answers. Okay, again simply I am giving first cyclohexane you are putting. What is ozonolysis? Just to break the bond and put the 2 aldehyde group. Then intramolecular aldol condensation. One aldehyde, this is here, this is alpha hydrogen is acting. It is going to add on this carbonyl carbon. So you are getting the intermediate minus water. Here what is the knowledge is in between alpha beta you put the double bond. Thank you children.